What are the origins of TR398? Who formed it? What is the motivation behind this?
Different AP vendors will have different access points. If you see gaming, streaming, handling multiple users, if your AP is unable to handle these scenarios, then it will be a problem, right? By considering all these factors, TR398 introduced by the broadband form.
What value does TR398 testing offer to AP vendors?
AP vendors definitely should follow this TR398 because if the AP vendor follow all these scenarios, it will let you to stand in the market.
Can you give us an overview of how do you test this and how your setups look like?
These are the stackable chambers. The TR398 spec defines 6 key aspects. So we should definitely follow all these guidelines.
Is there any AP that actually passed all the test cases that are there in the test plan? Hey everyone, welcome to Weekly Wi-Fi Wisdom podcast series where we talk everything about Wi-Fi and the tech that surrounds it. I'm Sainath, WLAN QA engineer at Candela Technologies, and today I'm very excited to introduce our guest, Mr. Manoj Kumar. He has been part of Candela Technologies since over 3 years. He's very much experienced in TR398 testing, and in today's episode, we will be talking about the same TR398 testing and its significance. Hey Manoj, I'm glad that you are here. Looking forward for your insights on TR398 testing.
Yeah, thanks, Sainath. Thanks for hosting me. Yeah, over the past 3 years, I've been working on that TR398, and we all know how the TR398 evolved. I'll be glad to discuss all my experience and on the TR398 front.
Yeah, great. I would like to understand with what are the origins of TR398? I mean, who formed it and what is the motivation behind forming this test plan? Could you please explain us?
Yeah, all right. TR398 is a standardized document developed by the Broadband Forum. So basically, this Broadband Forum is non-profit organization. They set some standards to test the access points and routers. They are in all domains. They like for like few years back they are into this Wi-Fi industry. They came up with the issue one test case, issue one document basically on 2019 with the some of the test cases. So the main goal behind of this TR398 is like till now before TR398 there were no standards. There were no standards on this testing router or access points. So simply the AP vendors used to do in-house testing. So for service providers, it will be very difficult to compare all the uh, router or like all the access points before putting into the market, right? So this TR300 focused on the real world scenarios and they developed these test cases to help the AP vendors or chipset makers or test equipment makers to actually follow this all the test cases for fairly uh, testing all the access point and comparing all.
Right. So you mentioned, yeah, I'd like to draw 2 points here. So you mentioned that in-house testing of access points, where vendors do their own thing,
Yes.
which the other vendor might not do,
Yes.
which he might not follow. And you also mentioned about fair comparison between access points.
Yes.
So from what I understand, it is more about forming a common ground and standardizing the test cases
Right.
for all the access points, irrespective of your brand.
Right.
If you want to follow this TR398 test plan, vendor A have to follow the same test cases, vendor B have to follow the same test cases.
Yes.
Yeah, I think that's very fair,
Right.
fair comparison, as
Right.
you said.
Right.
Yeah, and standardizing this test plan, I think it is one of the challenge that it addressed. May I know what other challenges that it is trying to address other than a standardized test plan?
Well, TR300 is try to set some context. Basically, let's say if you see some AP vendors, different AP vendors will have different access points, right? If you see some box, they are saying some 19,000, some are saying some 17,000, some will say some 10,000. But when it comes to the reality, the matters is like how well your AP is performing in the real life based on the real scenarios. If you see, like like recently, like we gaming, streaming, handling multiple users in real life, this is a big problem. If you're at that particular scenarios, if your AP is uh, unable to handle these scenarios, then it will be a problem, right?
Right, right.
So
Yeah.
by putting like by considering all these factors, TR398 introduced some performance metrics, like focused on this latency and also handling multiple users. So based on these conditions and all, they defined all these test cases, and they try to provide, and it helps to bring some transparency and consistency to the testing Wi-Fi performance of the router. Uh, so it will be helpful for the benchmarking the access points or benchmarking the performance to the AP vendors or service providers.
Right. So it is also addressing the performance evaluation, and also, as you said, real use cases like what happens if there are multiple clients connecting to the access point instead of just one or two.
Right.
And also, as you said, gaming where latency can be very critical.
Right.
I hope this covers all such use cases. Yeah, I think it's great that it is doing that. And now let's say if I'm an access point maker, I make APs, and why should I go for TR398 test? What value does it offer me? So, in your opinion, what value does TR398 testing offer to AP vendors?
Yeah, AP vendors definitely should follow this TR398 because, as I mentioned earlier, it covers the real aspects, like latency and this all, how well your AP will handle. Because the customers will care about this, right? Instead of if you consider uh, like long back, maybe 20 years back, the people used to actually buy the routers based on the cost. They at the time they were not care about this user experience, because at the time we used to like we had Wi-Fi to use, just sending an emails and all, right? Now so out of 100 homes, only 2 or 3 homes used to have this Wi-Fi connection to send an emails and all.
Mhm.
But when if you see now, uh, almost like 95 homes are having this routers.
Yeah, Wi-Fi
Wi-Fi.
got widespread.
Yeah,
Yes.
right. So now people are caring about the user experience, not for the cost. They want, like, they are going for most expensive also, because they are caring about this user and experience. So based on these real scenarios, they designed and they defined all these test cases, right? So if the AP vendor follow all these scenarios, right, then there will be a good chance of this competitive for their other vendor APs, right? This test case, like, once, let's say, the AP vendor passes,
Mhm.
the AP vendor AP passes all these test cases, then it will be uh, very easy to gain some confidence or trust for service providers and customers, and it will let you to stand in the market, right?
Right. So there is some competitive advantage to
Yes.
this. And also, as you said, if it qualifies TR398 test cases, I mean, if it passes, then there is some confidence,
Yes.
definitely.
Yeah.
So the AP can do well in that specific aspect.
Yeah. So if you consider, let's say, if your AP is passing all these test cases, and because since it covers all the real world scenarios, then, as I mentioned earlier, it will be very you will have some confidence to sell
Understood.
your
Yeah.
AP into the market.
Yeah. Thank you for sharing the historical context of TR390 testing and explaining what value it gets to the AP vendors. So, could you please explain us on a high level what are the test cases involved in this testing? Please give us a walkthrough of this testing. I mean, of this test plan.
All right. Yeah, the TR300 spec defines 6 key aspects, ranging from performance, RF capability, baseline performance, coverage, multiple stations performance, stability. and mesh performance. So in all these key aspects, in categories, they have defined some set of test cases with some proper procedure and some pass fail criteria and metrics, right? So if you take the RF capability, we have one test case called receiver sensitivity test. This is one of the beautiful and important test case for validating the access points of routers. So what this test defines is, um, the APR router can easily demodulate the stronger signal. Even if any router, if you consider any router, even it can demodulate the weaker signal, then we can consider that AP receiver capability is better, right?
Right.
So by this test case, we can test our router's receiver sensitivity capability. So they have some set of procedure and pass fail metrics, and we need to do all the orientations and applying some attenuations, and we'll be calculating the receiver sensitivity with some form of like following pass fail criteria. And
Okay.
also, if you see the baseline performance, we have this max connection test. Consider home scenario. In modern home, we'll have one access point and 20 or 30 devices uh,
Right.
connected to the same access point, and maybe they can the access point is serving simultaneously to the all these connected 20 or 30 clients. Either it could be download or upload, right? So in this scenario, the AP should uh, serve equally to all clients without dropping any packets, right? So this scenario we can test with this max connection test. If you consider airtime fairness test, let's say you have iPhone 16 and some have some iPhone 4 and some have some legacy mobile, right? So all these clients will connect to the particular router, and router should be able to handle, and it should give airtime like equally to all devices respective of their standards or whatever the rates that support, right? So that these kind of test cases based on the real world scenarios, it has defined like dual band, um, multi-band performance, bidirectional multiple stations performance, rate versus range, spatial consistency, and many more. Yeah.
Yeah. Thanks for giving an overview. So I'd like to come to receive sensitivity that you have mentioned. So you talked about orientation and different attenuations. So what do you do? You test? I mean, by varying the distance and at the different angles. Is that what the test case does?
Yes. So if you consider home, we'll be placing the access pointing in one place, right? So the users will actually roam across the room or home. So here the access point will be fixed. So some people can sit on some 90 degrees, some people can sit on some 180 degrees, and some people can sit on 270 degrees. We might know, right? So in every angle, the receiver sensitivity capability from the router should be equal, right? If your AP is receiver capability in 90 direction is good, and some 180 degrees, 180 at 180 degrees it cannot actually demodulate, then there is some issue with the AP, right? So like the TR398 specs specify that the AP should be perform equally and well in all directions. So that's why we are actually um, calculating the receiver sensitivity in all direction with the step of 30 degrees.
Understood. And what is the pass fail criteria for a specific iteration? So let's say you are testing at some angle at certain distance, and I think you run a throughput test. So how do you define if it is passing or failing?
Receiver sensitivity test.
Yes.
Yeah. So uh, we test, let's say you can consider, I'll talk about the procedure and all, maybe you can relate it. So if you follow the procedure, we'll set first maximum MCS, maximum MCS 11 you can consider, and the rotation will be the 0 and the attenuation will be 0, and we are running some traffic, some 1 cross 1 like 65% of the fire rate
Mm-hmm.
of minimal traffic, and we'll calculate the packet error rate.
Oh, so packet error rate is the deciding factor here
Yes.
for pass fail
Yes.
criteria.
So there is some certain attenuation value. The AP should not exceed 10% packet error rate
Oh, got
till
it.
that attenuation step,
Okay,
and that is your receiver sensitivity.
understood. So the 10% packet error rate is the key deciding
Yeah,
criteria for pass fail
yeah,
in this
yes, yes.
context. Okay. Okay. So if I can ask, what is the best receive sensitivity value that you have seen across all the APs that you have tested? What is the value, best value that you have seen in this test case?
Well, I can say minus 81 dBm or minus 82 dBm.
Okay. At that signal level, you saw all the communication being successful with less than 10% packet error rate.
Right, right.
Understood. Um, so Manoj, you have introduced few factors here, like you said multiple clients, you said distance, you said attenuation. So can you give us an overview of how do you test this and what how your setups look like? Maybe if you can walk us through the test setup, I think that gives us better context of how you are actually doing it.
Okay. If you see the setup, these are the stackable chambers. So basically, like if you consider the middle one, so that is the DUT chamber. We can see the turntable. On top of the turntable, we place the DUT, right? So we use the turntable. We control the turntable to rotate 360 degrees.
To
Uh,
get the different
Different
orientations.
orientations, right? And the bottom chambers, we have our equipment like traffic emulators, and we are emulating the clients using that box, and as well as we are generating the traffic. So all this cable, like all these units connected all the way to the cable through the attenuators. If you see here, there are some attenuators.
Yeah.
So these two chambers connected through this attenuator. On top of that, we have two chambers for, let's say, if we're considering the mesh scenarios, right? So we'll be having some root plus some extenders, right? So as per the TR printed spec, so one root plus two extenders. So the main root will be sitting on the DUT chamber, and node 1, node 2, that means extender 1 and extender 2 for the two chambers. So like that, we have this test setup. Yeah.
Understood. Thanks for sharing the insight. And I think the setup looks quite complicated with all the connections that are going behind and at the side of the test beds. I think whoever are testing this needs to maintain some proper documentation on this, uh, how the connections are going on. Correct?
Yes, since it is some complex um, connections, complex test bed setup. So basically, we follow wiring diagrams. So we made like we'll set up some wiring diagrams, and we follow the wiring diagrams. Based on that, we'll connect, because some misconnection leads some the AP will fail, right? So
Right.
yeah, we are.
Okay. So this is about you are emulating the clients right here. So let's say if I ask you how does this setup compare to the realistic scenarios in the real world, uh, and if I want to test this TR398 whatever test cases that you are mentioning in real world with real devices and in real space, is that possible?
Well, the TR398 standard, like the broadband forum, define these test cases based on the real world scenarios, right? So yeah, to replicating the same setup in the real world is very difficult, and it will require manual effort basically. See, so we are using here nearly 30 to 40 clients. So setting up all the 30 to 40 clients in different distances, and the main big problem is the automation, right? So it has very big procedure to follow, right? So without automation, you need to do like one by one manually. And also this actually this test defines for the repeatability, right?
Mhm.
So to test across different access points, so the repeatability should be there. So with the real world scenarios, we cannot expect the same results with the uh, next iteration, because interference effects, temperature effects, so we cannot guarantee on the result side, right? The repeatability is very less in the real world. And also as I mentioned, the automation will be the big challenge. So yeah, so that is mostly like this test case defines uh, and suggests to be tested in this controlled and lab environment to test across the different access points.
Okay. So it specifies more on the lab with a very controlled environment.
Controlled, yeah.
Understood. Okay. Quick question on the setup though. Since you are showing the setup here, so are there any guidelines specific to the testing setup in terms of having certain signal to the certain client in any specific test case? Did the standard define any such criteria?
Well, yes, yes. So basically, the test standard defines the client should be maintain minimal like 2 meter distance away from the router.
Okay, so the distance at which the test perform should be at the 2 meter
2 meter,
distance.
yes.
And is it common for all the test cases or
Yes.
only for some
Yeah.
test
So
cases?
all these test cases should perform by while maintaining 2 meter distance from the AP.
Okay.
Yeah.
Understood.
And also few things also there, like if you see there are antennas in the DUT chamber, that also like the partition, the difference between the placement of the antennas should maintain some form of the distance. And
Oh,
there is a reason behind it. Maybe once you can go through the draft of this TR398, you will understand how
so
this
they
distance.
actually define the distance between two
Yes,
antennas
two
also should
antennas
be at
also.
a specific value.
Yes, exactly.
Okay. Yeah, I think the guidelines are very much defined in the standard.
Yes,
I guess
exactly,
then.
exactly. So we should definitely follow all these guidelines before proceeding. So in our testing, like we do the calibration before performing any testing. So once we calibrated the setup, then only we'll start performing the test cases with the access points.
Okay. Yeah. So now let's see how this test plan is evolving over the years, right? I would like to know if there are any amendments that are happening to this test plan. You mentioned that it was introduced in 2019, and now here we are in 2025. So, are there any amendments that got pushed into the test plan over this span of 6 years?
Yes. Um, yeah, as I mentioned, the TR398 started on 2019. It was introduced issue 1
Mhm.
with some baseline performance test cases for especially for Wi-Fi 4 and Wi-Fi 5. And later on 2021, they came up with the issue 2. Uh, they did some refining to the testing methodologies. They have added few more test cases to the issue 2, and particularly to test residential Wi-Fi routers for standards Wi-Fi 6.
Okay. Keeping Wi-Fi 6 in mind, some
Yeah,
new test cases were
yeah,
added in
issue 2.
issue 2. Okay.
And then they came up with the support of Wi-Fi 6E for issue 3,
Mhm.
and they have added few test cases like latency, multiband, quality of service, mesh performance. Like, yeah, they have added all this. So based on the real world scenarios at that time, like the demand of this VR and the gaming, so the latency was a big problem. So they evolved the based on the real world scenarios. So they keep on added this new test cases to that.
Yeah, I think that's a good thing because the test plan needs updates as the time evolves, right? Because uh, the specific use cases of Wi-Fi also gets changed, in my opinion, because you also mentioned that mesh, addition
Yes,
of mesh could be a great example. Uh,
yes, yeah. When you see the mesh performance, right? So earlier, like we used to have homes like one bedroom apartment or two-bedroom apartment, which is one router is sufficient to cover all the areas, right? If you see like for uh, for two-story or three-story villa, like it will be very difficult to cover all areas with one router. So at that where we can use the mesh routers, right? And so that's why they introduced this mesh performance test as well in the issue 3.
yeah, putting coverage
Yeah,
as a use case, they have
and
updated the
yeah, and
test.
roaming is also one of the biggest challenge. So everyone should like from the user experience. So they should not see any delay or while watching movies or somewhere like while they're roaming, right? They don't want to see any lags or something. So
Yeah.
putting all this in mind, they developed all these test cases.
Understood. So, could you please share us any unique challenges that you have faced while testing this TR398, or if you could talk about any memorable bug or issue that you have seen with AP that you thought it is actually useful, right, for the AP vendor. Uh,
Yeah. Um, if I started talking about the issues that I have seen or my experience, then it will take hours and hours.
of
Because
course, but let's just stick to one. Maybe, yeah. Any one issue if you could talk about.
okay, so as a part of our pre-sales evaluation, for proof of concept, one of the vendor uh, sent us like two different models of APs, and they asked us to test that full TR300 test case and compare the results between those two APs. And I started working on those APs, and I started completed one set of the test cases with the one AP, and then I started completed the second set of the test cases also with the second AP, and then I started comparing the both results with the both APs, right? Then I found that one of the test case called multiple stations performance, which was passed by the AP1 and which was failed with the AP2. Then I started debugging it because we did not change anything like from the setup side. The environment is same, and the placement of the AP and all the same test cycle we repeated with the AP2. So surprisingly, it failed. Then we started debugging it to narrow down the problem. Uh, so let me just explain this multiple station, what it does, the
Yeah.
multiple station performance. It defines, let's say there will be three groups, um, like first group, second group, third group. First group will have some set of clients, and second group will have some set of clients, and third group will have some set of
How
clients.
many number of clients?
Three clients will be in each group. Total
Okay,
9.
per group, 3 clients.
Yeah, per group 3 clients.
Okay.
And then the group 1 will be the near to the access point, and group 2 will be some medium distance to the access point, and group 3 will be the far distance from the access point. If you consider like in real home, so few of the
Correct.
devices connected very near to the router, and few of the devices connected from the bedroom to the medium distance, and few of them can sitting on the balcony and connected to the same router, and they can do something, right? The same scenario they replicated in the sea, right? So yeah, that the procedure actually, first it will run the traffic with the group 1, upload and download, then group 1 plus group 2.
Oh, both of them at the same time.
Yeah, simultaneously.
Okay.
Then near, medium, far, group 1, group 2, group 3.
Okay. Okay.
So the test passed with the group 1 and group 1 plus group 2, and it failed with group 1 plus group 2 plus group 3.
Okay. In that specific iteration,
It got failed.
Okay.
And then to narrow down this problem, I compared, there is another test case called rate versus range, right? So this is a similar test case basically. The rate versus range, we know, right? Initially, like we keep on increasing the attenuation, and we will verify the performance over the range, right? So the rate versus range passed, the AP, the both APs are passed with the rate versus range, and this multiple stations performance got failed.
Okay. But Manoj, I think in rate versus range also there is that far aspect, right?
Yes, yes.
But this AP you are saying.
Yeah, they both performed equally. There is no difference. That's what.
Yeah, but how is that? Because the far aspect is there in both the test
Yes,
cases,
yes,
and you are saying it got passed in rate versus range,
yes.
but not on the multi-client.
Yeah, multiple station performance test. Yeah, then we started narrow down this problem, and we gone through the packet captures, and we analyzed all the packet captures like MCS rate, NSS rate, aggregation, and all. Upon our analysis, like we found that the there is some higher percentage of retries on the with failed AP when compared to the past AP. Then we realized the rate scaling algorithm of the AP is not working as expected, because the rate scaling algorithm we need to develop in the AP in such a way that based on the percentage of the retries, it should set the rate scale. Let's say if the higher there are no retries, then it should set the rate scale some MCS 9 or max MCS 11. If you are seeing the minimal retrace, then it should set the rate scale some to it should decrease the MCS rate like 8 or 7. If as you are seeing higher MCS rate, it should decrease the lower MC, like uh, as you're as
Yeah,
you
you
see,
mean high retries? Then
yeah, as you're seeing higher retrace, then
should
it should decrease the MCS rate,
okay. Yeah.
right? uh, yeah, so in this case, the AP is, even though higher retrace, the AP is picking the higher MCS rates. So
Oh,
when
I
we
see.
compared with the both APs, the AP2 will have some more than 10% of the retrace, and AP1 will have some 1 or 2% of retrace.
Okay, AP1 is performing comparatively better than AP2.
AP2.
But still AP2 will have high retries in both the cases, right? RVR and
Yes, that's where this test case added value. So in the rate versus range, in the traditional RVR, so we had only one client, right? So if you take 100% of medium utilization, so 10% of the AP did not affected the 90% of the medium utilization. But here the case will be the multiple clients, and different clients are using different MCS rate. There is no room
oh, I see.
for AP to actually transmit still, even though like having 10% of the retrace.
So it's like one client versus handling here, how many near and medium and far you are combined leading.
Yes,
So 9 clients.
yes, 9
So
clients.
1 versus 9.
Yeah. So by this test case, like personally, I felt TR390 is one of the best test plan covering all these type of aspect areas, because these kind of issues we have found by these test cases, which was not seen in this traditional RVR test cases, right?
Right.
So that's why I personally felt this TR398 actually covering all the real world scenarios, and uh, helping the vendors to fix all these issue before getting into the market.
Right. Yeah, I think that's a very interesting issue as you described, right? It's like it could handle a single client, but when
But
it's coming to multi-client scenario and at the far distance,
right,
there is some issue there.
right,
Yeah. Um, Thanks for caring that,
yeah,
Manoj. It was indeed interesting.
right.
Yeah. Now, I'd like to ask you, like, how many years have you been in testing this TR398 thing?
Since I joined,
So it's like you have that hands on for all these 3 years, right?
yes, yes, yeah.
And may I know the rough count of the number of APs that you tested so far in TR398?
Um, Probably more than 30 to 40 APs, nearly that 40.
Okay,
30 to 40.
let's say 40. So you have tested 40 access points, and you mentioned there are lots of test cases. How many test cases overall?
If you consider issue 4, um, we have around 25 test cases.
Okay, so there are 25 test cases, very well defined by the test plan, and you have seen 40 access points performance for all these 25 test categories. So I'd like to know what is the best performing AP, or is there any AP that actually passed all the test cases that are there in the test plan?
I think this is, yeah. So, yeah, based on my experience, like I have seen, like as I mentioned, 6 key aspects, right? Some RF capability and baseline performance, coverage, stability, multiple performance, and mesh performance. Like some APs are good at RF performance and baseline performance, and they failed at coverage and stability. Some APs good at stability and coverage, they failed at baseline performance and RF capability. And yeah, 90% of APs like failed at least in one aspect. But
Okay.
yeah, there was a one AP recently, like when I tested, surprisingly it passed 100%.
Oh, so it passed all the test cases that you
Yeah,
had tested on.
out of 40 APs, this is the only one AP passed 100%.
So, in this entire experience of yours, you have seen just one access point.
Only one access point.
Uh, that's interesting.
Yeah, I double check everything still, because till then I never seen any AP that passed 100%, because If you see all these test cases and the pass-fail criteria, very, very strict pass-fail criteria.
Right.
So if you consider any one of the test cases called some bidirectional test case, there will have run some bidirectional traffic, and the packet error rate, the packet drop should not be more than 0.001%.
Oh, so the pass-fail criteria is
Yeah,
down to
0.001%. Yes,
granular.
yeah. If your packet drop is more than 0.01%, then it will indicate as a fail. Even one iteration failed, the entire test case got failed.
Okay, and this particular AP has passed
Passed
even
with the-
such
conditions.
strict
Yeah.
pass-fail criteria.
Yeah.
Yeah, that's very interesting to
Yeah.
hear. I feel that AB is very versatile in
Yes.
handling all such
Yes.
complex
Yes.
test scenarios.
Yes.
Yeah. So that's all we have for today. So I think if any one of you are new to TR398 testing, I hope you got some valuable insights. I would like to thank Manoj for joining us and sharing all his valuable insights from his TR398 testing experience.
Yeah, thanks, Aina. Thank you for inviting me to share my experience on TR398, and I hope it will help at least some people who are working on the TR398. Yeah.
Thanks for watching and please stay tuned for further episodes. Yeah, please like, share, subscribe. We'll meet in the next episode. Thank you.